Greetings to the respected HOD and all my respected teachers of the AC department of Gauhati University. I am here to give the presentation on the final year project that we have done on the topic face recognition using image processing. The project is done by me, RAJITA PEGU, along with my project partner LUTFUR RAHMAN, student of 8th semester. The project is done under the supervision of Professor Kandarpa Kumar Sarma. Here is the outline of the presentation. First, I will begin with the introduction, then literature review, motivation, advantages and disadvantages, working methodology and approach, software algorithm, problem formulation, Gantt chart, and finally with the conclusion and the outputs. Let's begin with the introduction here. Before moving into the details of this project, first of all, let us know what is this project all about. The main aim of the project is to create an automated face recognition system. Now, what is a face recognition system? In simple words, it is a personal identification system that uses personal characteristics of a person to identify the person's identity. It is based on computer application that is capable of detecting, tracking, identifying, or verifying human faces from an image or video which is captured by using a digital camera. We see that in the modern world, everyday actions are increasingly being handled electronically instead of using a paper or a pencil. And this growth in electronic transactions results in great demand for fast and accurate user identification and authentication. So, we have tried to develop this project in a simpler and easier way. This is a literature review here. We have referred to some sources for doing this project, so the sources are given here. The motivation for doing this project is that, firstly, it solves the problem of accuracy and allows for high enrollment and verification rates. Let me explain this by taking an example here. Suppose we need to access codes for identification and security clearances, which often use PIN numbers. So, in this case, using the proper PIN can gain access, but the problem is that the user of the PIN is not verified here. Hence, in this case, we can solve this problem by using a face recognition technology. Secondly, it also requires no physical interaction on behalf of the user, as well as it can use our existing hardware infrastructure, existing cameras and image capture devices which will work with no problems. There are also advantages and disadvantages of this system. The advantages are that this technology gives an improved security with easy to integrate and automated identification. There are also disadvantages of this system, like it requires a massive data storage burden, as well as detection is vulnerable and there is a potential breach of privacy. Now let's walk into the working methodology and approach. First of all, let us know the overall view of the project. The project has two important parts, the face detection part and the face recognition part. So first, we are going to deal with the face detection part and then with the face recognition part. For the face detection part, we will require an input image consisting of human faces. Then from that image, we will detect faces from which the facial features like nose, eyes, mouth will be extracted out. Hence, these extracted features will be then useful for the face recognition purpose, where we will be training and testing the images, and then finally we can go for the verification process. As I have said that there are two important parts, the face detection and the face recognition part. It is very much important for us to understand that the face recognition is not as same as face detection. Face recognition is the task of identifying an already detected object as a known or unknown face, and on the other hand, face detection is to determine whether human faces appear in a given image and where these faces are located at. Now let's move into the detailing of the face detection process. For this, First, we are going to enroll the faces of the people. Then, using a good quality camera, a database is created for these image faces in order to validate the input face. So, a camera will take minimum of 10 pictures of a single person from different angles and set as a database. Now comes the execution part. For this, a new image is captured using a good quality camera, or else we can do by capturing a video of people present, which will be then generated into an image by generating a frame there. This frame generation process is done so that only the necessary part of the video where the faces of the people are visible is extracted out and the unnecessary duration of the video is left out. Hence, we take the image of the people which will be used for detection of their faces. For this detection of the faces step, we have used the image processing technique. Hence, we create a MATLAB code here and generate an image with detected faces. The next important part of this project is the face recognition here. For recognition of the face, the first thing that we need to do is the feature extraction. So, after the face detection step, human face patches are extracted from the images. But there is a disadvantage if we directly use these patches for face recognition, because patch usually contains over thousands of pixels which are too large to build a robust recognition system. And secondly, these face patches may be taken from different camera alignments with different face expressions, illuminations, and may suffer from occlusion and clutter. So, to overcome these drawbacks, feature extractions are performed to do information packing, dimension reduction, salience extraction, and noise cleaning. After this step, a face patch is usually transformed into a vector with fixed dimension. This is how we can get an extracted features of the face. After the feature extraction process, now comes the comparison for a match of the faces against the enrolled faces. This process includes two important procedures. One is training and the other one is the testing procedure. First, we are going to perform the training procedure and then the testing procedure. For the training procedure part, as I have explained earlier, that for each person, several images are taken and their features are extracted and stored in the database. Then, when an input image comes in, we perform face detection and feature extraction and compare its feature to each face class stored in the database. So, in this way, we can generate the trained images. Then comes the testing procedure. Here we are going to test the newly uploaded images, whether it is recognized or not. So when we upload a new image, this image will be compared with the previously loaded images that is stored in the database and will show up either that new images is recognized or not. There are two general applications of face recognition. One is called the identification and other one is called the verification. Face identification here means that when we give a facial image, we want the system to tell who he or she is or the most probable identification that it can make. While in the other hand, a face verification is the process where a given face image and a guess of the identification, we want the system to tell true or false about the guess. Here comes the software algorithm now. First, we will deal with detection of the faces from the images, which will be followed by alignment, normalization, representation, and matching. Moving on to the problem formulation now. The problem formulation comes with the capture of the image or a video, then detection of the face from the image, and finally with facial features extraction and recognition. This is the Gantt chart here. We have completed all the tasks according to the plan. Now I will be showing the output with screenshots and working videos. Since the first step to do for this project is to create a database, so first I am showing the output for a database creation. When we run the MATLAB code for the database creation process, it captures the images of the person using the webcam. Suppose if we hide our face using our hands, then it will be prompting that no face is detected. So it is also showing that no face is detected in the figure. Finally, all the captured images are saved in one folder. After creating the database, we will try to detect the faces of multiple people present in that image. These are the detected faces of 3 people shown with a box around the face. Now here I am showing the working video clip for the database creation. After running the code, it is asking us to enter the number of required frames. I am entering here 20, so it is going to capture 20 images of one person. Here, when I hide my face, so here no face is detected, and the prompt is also giving that there is no face detected. So total 20 images is captured here. After capturing those 20 images, these images will be saved in one folder, and this folder is shown here where the 20 images are captured and saved. Now I am showing the working video clip for the multiple face detection. After running the code for the multiple face detection process, we need to select one picture. It is a group picture that I have selected here, consisting of 3 people. So the faces of these 3 students are detected. After completing the face detection part, we are moving on to the face recognition part. So here is a working video clip for the face recognition done. In the face recognition system, I have created 2 different folders. One is a training folder and another one is a testing folder. This is the training folder where I have captured 10 different images of one person and saved it here so that these 10 images will be further useful for the training purpose. And then moving on to the testing folder, here I have inserted those same 10 images that was inserted in the training folder, but these 10 images are distorted in some way. Then these images will be further useful for the testing purpose. After creating the training and the testing folder in the earlier stage, here is a working video for the execution of the training and testing of the images. This is for training the images. For executing the code, let us run. It is asking me to enter the number of images for training, so I am entering here 10. Then enter the number of dominant eigenvalues to keep as 50. After pressing enter, the training started. So here we can see that the training has started and the machine is busy. And depending on the speed of the machine, it takes around few minutes. Therefore, in my machine, it takes around 3 minutes. I'll wait till my training finishes. For now, the training has been done for only one person. So, the 10 different images that has been captured for one person, those 10 different images are undergone for training now. Okay, now we can see several variables are created in the workspace. So, small lamp in the workspace shows the main image. Now let us see the main image, how it looks like. First, I am reshaping it because the image is of 1D. So to convert this into 2D, we have reshaped the image. This is a 2D image of 200 by 180, and now by I am sure the image is shown. Hence, this image is trained image, as we have seen that the images earlier were taken in the colorful form. After training, it is converted into a grayscale image. Now let us move into the testing of these images. After running this code, we can see that these are the trained images which are not useful for testing. So we have chosen to take the images from the test folder. So we can see that the query image has been recognized here. To see the robustness of the system, I have taken the distorted images purposely. So when I take another image which is completely distorted, that image is also recognized here. Suppose if I take another image which is not a distorted one. Suppose this image is not distorted one. So this non-distorted image is also recognized here. So finally, we have seen that how a face recognition system is made, starting from the beginning where we created a database for the faces, and then we have created how to detect faces from the captured images. And finally, we have trained and tested these images for the recognition purpose. Finally, here comes the conclusion. So the conclusion is that the face recognition technologies have been associated generally with very costly top secure applications. Today the core technologies have evolved and the cost of equipment is also going down dramatically due to the integration and the increasing processing power. Certain applications of face recognition technology are now cost-effective, reliable, and highly accurate. As a result, there are no technological or financial barriers for stepping from the pilot project to widespread deployment. So our aim, which we believe that we have reached, was to develop a method for face recognition that is fast, robust, reasonably simple and accurate, with a relatively simple and easy to understand algorithms and techniques. That's all for the presentation. Thank you.